These are the solutions for the practice test called Free Response Chapter 3 Test B Practice Test. So let's take a look at our first problem here. And what they're asking us to do is find the prime factorization of the number 100. And so when I see those terms, what I'm going to do is I'm going to make a factor tree. I'm going to think of numbers that I can divide into 100 evenly. And so the first number that comes to mind is 4 times 25. Whenever numbers end in double zeros, 25, 50, or 75, I can divide it by 25. And from there, I need to break it down further. See, 4 can be broken down to 2 times 2. 25 can be broken down to 5 times 5. So once I've got it in this form where each of these factors is a prime number, then I have completed the prime factorization. So I'm going to write the answer this way. Since there's two 2's, I can write 2 squared times by, again, since there's two 5's, I'll write 5 squared. That is the answer I'm looking for. Here they're asking me to write the composite number for 2 times 3 squared times 5 to the third. So what I would do is I would take these numbers with the exponents and multiply those out. So 3 squared is 9, and I'll bring down this 2. And then 5 to the third, well, 2 5's make 25 times by 5, and 25 times 5 makes 125. So from this point, I'm not done yet. I still need to multiply these numbers. Now, instead of doing 2 times 9, I'm going to do 9 times 125. And so I'll write that down here, 125 times by 9. And when I do this multiplication, I end up with 45, carry the 4. 9 and 2 make 18 plus 4 makes 22. 9 and 1 make 9 plus 2 makes 11. But then I have to double that number. See, the reason why I did the 2 last is because doubling the number is not so hard. If I knew double 1,000, I could come up with that. That's 2,000. Double 125, that's 250. So there's my answer. 2,250 is the composite number. Now it says to write the prime factorization of 88. So we're going back to the same directions as number 1. So all I need to do is break this 88 down. And so 8 times 11. Well, 11 is prime, but 8 is not. So I need to break that down. It's 4 times 2, and 4 can be broken down to 2 times 2. So I need to make sure I bring down these other numbers so I don't forget about them, and then write them all down. So this is the prime factorization. However, we're going to write it with exponents. So 2 to the third times by 11 is what I'm looking for. Here it says list the prime numbers between 10 and 20. So if you weren't sure, well, just list these numbers, okay? Here's 10. So between these numbers, so 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So between means these numbers right here. So I'm looking at these values. So I need to find the prime numbers. Well, prime numbers are ones that only have factors of 1 and itself. So 11, that's prime because I can't divide it by anything except for 1 and 11. 12 has factors of 2, 6, 4, and 3, so that wouldn't work. But 13 is prime, has just 1 and 13. 14 has factors of 2 and 7, so any even number is not going to work, so we can cross those out right away, the even numbers. Because all even numbers you can divide by 2. 5 goes into 15, so that's not going to work. So the only ones that are left are 17 and 19. We already circled 11 and 13. So those are the numbers, 11, 13, 17, and 19. Next one asks for the greatest common divisor. That's the GCD, greatest common divisor. What can we divide both of these values by? And so what I do is I look for a common factor, and if I don't see it, I just break these numbers down. So I see 20 has factors of 4 and 5. Now I picked 4 rather than 2 and 10 because I see 4 goes into 16. See, 4 times 4 makes 16. Now if you look at it, the greatest common divisor is the one that they have in common. So 4 they have in common. They also have 2 in common, but 4 is the biggest number. Now, I can't do anything bigger because the factors that are left are 4 and 5. And 5 and 4 don't have anything in common. So 4 is the greatest common divisor. Now we have to do the same thing, but for 3 numbers. So look at the numbers and look to see if you see something in common. Well, they all either end in a 5 or 0, so I know 5 goes into these numbers. So 5 times 3, and this would be 5 times 6, this would be 5 times 9. But we see 5 goes into all the numbers, so the greatest common divisor has a 5, but it also has another number. Because if you look at these, this one has a 3, 6, and 9. Well, 6 and 3 aren't the same, but 3 goes into 6. So let's break that down further. 3 times 2, and this would be 3 times 3. And I'll bring that 5 down. I'll bring the 5 down over here. And this one already is broken down. So let's see if they have anything else in common. Well, they all have the 5, we saw that, but they also all have a 3. You see how each of them has at least one 3. This one has 2 3s, but they don't have 2 3s in common, only 1 3. This one only has 1 3, 1 3, 1 3. This one has a 2, but none of the others have a 2. So we also have to multiply by that 3. So 15 is the greatest common divisor. Well, looking at our next one, it says Tina is making identical bunches of flowers. She has 16 daisies, 24 sunflowers. What is the greatest number of bunches? Greatest number of bunches. So remember, the bunches are like clumps of flowers together that they bundled together. So we would have like a bunch here, a bunch here, a bunch here, and a bunch here. So notice that we're going to have some number of daisies and some number of these sunflowers bunched together in this group. And so we want to find out the greatest common divisor. How many of these bunches will go into 24 and 16? So here they're talking about the greatest common divisor. And so, and the reason again is because the greatest number of bunches Tina can make using all the flowers. So this tells me it's the greatest common divisor, so I'm just now taking the 16 and the 24 and breaking it down. But look for the biggest number that goes into these. You see, I see 2 goes into them, but I'm not going to start there. I see 4 goes into them, but I see a bigger number. I see 8. See, 8 times 2 makes 16, and 8 times 3 makes 24. So 8 is the biggest common divisor. And so if you didn't see 8, well, then you could always keep on going until you break down the number, just like I didn't see 15 at first in these 3 numbers, but eventually I would get there if I continued breaking the numbers down. So what this means is the greatest number of bunches would be 8. 8 bunches. And just to show that we understand the problem a little better, there would be 2 daisies per bunch, and there would be 3, see there's 3 of the sunflowers in one bunch is what we'd have. But their answer that here they have is just 8. So 8 bunches. Well, looking at the next one, here they're talking about the least common multiple. Multiples are bigger numbers. These are numbers that the 3, the 5, and the 12 go into. Rather than finding numbers that go into these numbers, we're trying to find numbers that these values, or one number that these values go into, but they want the least one. So what we're going to do is start with the biggest number and write its factors, 3 and 4. And then you can break this down to 2 and 2 if you wanted to. Well, this means that I need a 12. I need a 3, a 2, and a 2 that make up 12 in my number. Now let's go to the smaller numbers. Is 3 already a factor? Yes, it is. So we're done with that one. We're done with 12 as well. Now, is 5 in here? Can we make 5 from these numbers? Well, not by multiplying, so let's go ahead and put the multiplication of 5 in there. And now let's go ahead and multiply these numbers. So this makes 10. This makes 6. So 6 and 10 make 60. That is the greatest common multiple. Same thing here. Again, take the biggest number and break it down. So we already know it's 3 times 4, which would break down to 3 times 2 times 2. So I break the number down this way so you can see all the factors. See, 4 is already made up of this number. See the 2 times 2? 4 is already there with these 2 numbers right here. Those 2 multiply to make the 4. So we don't need to multiply by another 4. Well, 10 already has a 2, so we don't need another 2. But we do need a 5 because I don't see 5 there. So I need to multiply by that. And so when I multiply this, I get the same answer. I get 60 once more. And what that means is I can divide 4, 10, and 12 into 60. Just like I can divide 3, 5, and 12 into 60 as well. So that's called the least common multiple. Well, the next problem says, for exercise, Jenny jogs once every 4 days. once every 4 days. Her friend Kim swims once every 5 days. If they both exercise on the same day, in how many days will they exercise on the same day again? So this means these are factors of this bigger number. They're asking for the least common multiple. See, over here it was the greatest number of bunches. Well, that would be the greatest common divisor. Here they're saying, when will they end up doing the same thing on the same day? Well, that would be the least common multiple. What numbers do these values go into? Well, the least one would be taking those two numbers, 4 and 5, and breaking them down. And I see that 2 times 2 are the only numbers that 4 will go into, but here 2 does not go into 5, so I need to also have a 5. So I multiply those, and there it is. It will be 20. So 20 days is when they'll end up doing the same, or exercising on the same day again. Well, looking at the next one here, it talks about to write a fraction that is equivalent to 6/15. So there's lots of answers here. You could have multiple answers. You could have multiplied this by a common factor as long as it's the same number on top as the bottom. See, this makes 1, and 1 times a number won't change the value. So if you said 12 over 30, that would be a common factor. But you could have reduced it. See, 6/15 has a common factor of 3. So you could have divided by 3 over 3, and that's like dividing by 1. So it's not changing the value of that number. So if you said 2/5, that is the same answer. So 2/5 is the same as 12/30. So it doesn't really matter what number you multiply on the top and the bottom as long as it's exactly the same. Does the fraction reduce to the same value of 2/5? Well, 12/30 also could reduce to 2/5. So these are possible answers. So here the answers could vary, and the key is to make sure you multiply by the same number on top and bottom. Just like here, I divided by the same number on top and bottom. Well, let's take a look at the next few problems here. So moving over to this page, I have to write the improper fraction that is equivalent to 3 3/10. And so if I was to do this, what I would end up doing is I would take this 3 and multiply it by 10 and add 3. And so that's what we do. We take the denominator of the fraction and multiply it by the whole number. So 3 times 3. That's where these two numbers are coming from. But then I'm adding the numerator. So this 3 right up here, that's what I'm adding. And it's all over the divisor of 10. So it's always over that divisor of 10. So I go ahead and multiply, and this makes 30 plus 3 all over 10. And so that gives me 33/10. And that would be my answer. Well, looking at our next one, it says to write the fraction 10/12 in simplest form. So what I want to do is take out a common factor here. I want to take out 2 from both of these numbers. And so when I do that, I end up with a 5 over 6. And that is the fraction in simplest form. Well, let's take a look at our next one here. It says to write 16/3 as a mixed number. Well, when you do this, all you're going to do is divide 3 into 16. How many times does 3 go into 16? Remember, top dog in the doghouse, the divisor on the outside. Well, 3 goes into 16 5 times, with 1 left over. Well, whatever the remainder is goes on the top of the fraction. The divisor is always the same, so it's 5 and 1/3. And we'll go ahead and finish up the rest of the problems in the next part. So check part 2 for the rest of the problems.